Hello students and friends. Today's video focuses on biological effects of radiations. So stick around, watch and learn. Our introductory question is, which of the following units is the least directly related to the biological effects of radiation? Option letter A, Sievert. Option letter B, Gray. Option letter C, Curie. Option letter D, Rem. Option letter E, Rad. And option letter F, Roentgen. The correct answer is Curie. Stay tuned and wait until the end of this video for more explanations why the answer is Curie. In the field of dosimetry, which is the measurement of radiation exposure to both ionizing and non-ionizing radiations, we have some important terms to remember. First in the list is absorbed dose. This refers to the energy delivered to the tissue per unit mass. Its SI unit is the gray. And 1 gray, we say, is equal to 1 joule of energy per kilogram of a body tissue. An older unit is the rad, okay? And 1 rad is equivalent to 0.01 joule per kilogram or 0.01 gray. Next important concept is the so-called relative biological effectiveness, abbreviated RBE, or simply sometimes called quality factor QF. The RBE for several types of radiation are given here in this table. Its unit RBE expressed in Sievert per gray or Rem per rad. So for X-rays and gamma rays, we have the standard value of 1. For electrons, it ranges from an RBE of 1.0 to 1.5. For slow neutrons, the RBE ranges from 3 to 5. Protons has an RBE of 10. Alpha particles have 20. And heavy ions also have 20. Based on the given RBE for the different types of radiations, it can be deduced that the absorbed dose or the amount of energy per unit mass, okay, expressed in kilogram, it does not really give us an accurate way of describing the effects of radiations. So it looks like, according to the table, different types of radiations okay, have different effects on a given mass or body tissue. So, a third important concept is what we call the biologically equivalent dose, or simply called equivalent dose, expressed in the SI units sievert. All right, and this is determined by multiplying the RBE, or the relative biological effectiveness, multiplied by the absorbed dose. All right, so if the absorbed dose is expressed in gray, the unit for equivalent dose is the sievert. All right, if the absorbed dose is expressed in rad, multiplying that by the RBE will give us the equivalent dose expressed in rem. Rem is just the acronym for what we call Roentgen equivalent in man. So that's an abbreviation or acronym for Roentgen equivalent in man. Roentgen used to be a unit of radiation exposure, but it has been replaced by this unit rem. All right, 1 sievert per gray or 1 rem per rad are just equivalent, so that when we say 1 rem, it is just equal to 0.01 sieverts. All right, so the unit of RBE, or the relative biological effectiveness, can either be sievert per gray or rem per rad, depending on what unit of uh, radiation or absorption dose you're going to use. If it is in rad or if it is in gray. So we have our first problem, or question number 2. If a person's entire body is exposed to 5.0 joules per kilogram of X-rays, death usually follows within a few days. Question letter A. Express this lethal radiation dose in gray, rad, sievert, and rem. Question letter B. How much total energy does a 70.0 kilogram person absorb from such a dose? And question letter C. If the 5.0 joule per kilogram came from a beam of protons instead of X-rays, what would be the answers to parts A and B? We'll have the solution and answers to these questions in a short while. Alright, so since we are given the absorbed dose of X-rays, which is equal to 5.0 joule per kilogram, our answer to letter A, what is the absorbed dose in gray? It is exactly 5.0 joules per kilogram, which is 5.0 gray. And how much is this in rad? Alright, so we just convert 5.0 gray to rad, that is, by multiplying 5.0 gray by the conversion factor, 1 rad has 0.01 gray. So the unit gray cancels out, and what we have is 5.0 times 10 to the second power rad, or 500 rads. Now for the equivalent dose, it's formula is just equal to the RBE, or the relative biological effectiveness of X-ray, multiplied by the given observed dose in gray. All right, substituting the RBE for X-ray is 1 sievert per gray, multiply that by 5.0 gray. The unit gray cancels, and we have the equivalent dose equal to 5.0 sieverts. Now, this amount of equivalent dose in sievert, when converted to rem, all we have to do is use the conversion factor where 1 rem is equivalent to 0.01 sievert. All right? So 5.0 sievert times 1 rem divided by 0.01 sievert. The unit sievert cancels out, and we have the equivalent dose equal to 5.0 times 10 to the second power rem, or 500 rems. All right, for question letter B, we are asked to find the total energy absorbed by a 70.0 kilogram person, okay, given this dose. All right, so what we do is 5.0 joules per kilogram, that's the absorbed dose, just multiply it by the mass of the person, which is 70.0 kilogram. Okay, kilogram cancels out, and we have the total energy absorbed by the person equal to 350 joules. All right, so in answering letter C, we are given the absorbed dose equal to 5.0 joules per kilogram, but this time, okay, this absorbed dose 5.0 joules per kilogram are assumed to be coming from protons instead of X-rays. So we'll be answering the same questions in letter A and letter B. All right. So the previous answer we got 5.0 gray as well as 5.0 raised to the second power rad will stay as they are. All right. We will only change our computation for the equivalent dose because the RBE for protons is not the same as the RBE for X-rays. All right. For protons, RBE is equal exactly to 10 sieverts per gray. So when you multiply that by the given observed dose in gray, which is 5.0 gray, we will get the equivalent dose of the radiations coming from protons equal to 50 sieverts to 2 significant digits. All right. And for the equivalent dose in rem, all right, doing the same formula, but we will use the absorbed dose in rad, that is 5.0 times 10 to the second power rad. So multiplying that by the same value of RBE, okay, 10 rem per rad, the unit rad cancels out, and multiply 10 by 5.0 times 10 to the second power rad, we will get the equivalent dose in rem equal to 5.0 times 10 to the third rem, or that is 5,000 rems. For our last question, question number 3, a cobalt-60 source with activity 2.6 raised to the negative 4 curie is embedded in a tumor that has mass 0.200 kilograms. The source emits gamma photons with average energy 1.25 million electron volts. Half the photons are absorbed in the tumor and half escape. Question letter A. What energy is delivered to the tumor per second? Question letter B. What absorbed dose in rad is delivered per second? Question letter C. What equivalent dose in rem is delivered per second if the RBE for these gamma rays is 0.70? And question letter D. What exposure time is required for an equivalent dose of 200 rem? Alright, so for our initial solution, we first take note that the nuclear reaction for the isotope cobalt-60 to produce gamma photons is shown in this equation. All right. So cobalt-60, which is an isotope of the cobalt element, when it emits gamma, it actually becomes uh, the isotope nickel, whose mass number is also equal to 60. All right. But of course, the atomic number from 27, that of cobalt, it's now 28, all right? Because it also emits an electron or a beta minus particle, all right? So this is uh, the nuclear reaction or transmutation that happens when the isotope cobalt-60 emits gamma photons. And it's also indicated in the problem that the activity of this uh, cobalt-60 isotope, okay, is 2.6 raised to the negative 4 curie. So we need to convert that to our SI unit of activity, which is becquerel. So since in 1 curie there are 3.7 raised to the 10th becquerel, so we just multiply this, the unit curie cancels out, and we get the activity for cobalt-60 equal to 9.6 raised to the 6th power becquerel. Right, moving on with our computation, we say that the activity of 9.6 raised to the 6th power becquerel simply means that there are 9.6 raised to the 6 nuclei of cobalt-60 isotope that transmutes in a time of 1 second. So, if according to the problem, the energy that is associated to the gamma emission, all right, gamma photon emission is 1.25 million electron volts, okay, we convert this to the usual unit of energy, which is joule, all right. We just multiply this by the conversion factor, which is in 1 million electron volts, okay. The equivalent is 1.603 raised to the negative 13 joules. So 1.25 million electron volts is equal to 2.00 raised to the negative 13 joules of energy. All right? And since the meaning of 1.25 MeV is per nuclear transmutation, in other words, for every isotope, all right, or nucleus of the cobalt-60, uh, the accompanying amount of energy that is associated to the release of gamma photons is 1.25 million electron volts. And since, based on the activity of the cobalt-60 source, all right, which we have determined in terms of becquerel, all right, there is a need for us to multiply that, this amount of energy of 1.25 million electron volts already converted to joule, there is a need for us to multiply that by the number of what we call transmutations, all right, or disintegrations equivalent to 9.6 raised to the 6 nuclei of cobalt-60. And then, according to the problem also, only half of this total energy is absorbed by the tumor tissue, half of which has escaped. All right? So, multiplying this and then divide by 2, we will get the total energy that is absorbed. Okay, it's 9.6 raised to the negative 7 joules. All right. So we say that the absorbed dose, all right, absorbed dose, which is the amount of energy per unit mass, and since the mass of the tumor is 0.200 kilogram, so that energy, 9.6 raised to the negative 7 joules, is divided by 0.200 kilogram, and we get as the absorbed dose equal to 2.4 raised to the negative 5 gray. All right, that's the answer to question letter B. And then we want to also express this in the unit rad. So we just convert gray to rad using the conversion factor that in 1 rad there is 0.01 gray. All right. So doing our math, we will get as the absorbed dose expressed in rad equal to 2.4 raised to the negative 3 rad. And moving on to question letter C, what is the equivalent dose for this absorbed dose, all right, given that the RBE, all right, or the relative biological effectiveness of gamma radiation, which is 0.70 rem per rad, all right? So, equivalent dose, as earlier discussed, is just determined by multiplying this RBE by the given absorbed dose in rad. All right, the unit for RBE here is rem per rad. So multiplying that by the absorbed dose in rad, the unit rad cancels, and we get this equivalent dose already in rem, which is equal to 1.7 raised to the negative 3 rem. All right, now let it be understood that this equivalent dose or the absorbed dose or this total amount of energy, all right, this is specifically for 1 second. In other words, when the tumor has been exposed to this equivalent dose, 1.7 raised to the negative 3 rem, this is only in 1 second. All right? So that brings us to question letter D. All right? Question letter D is asking us to determine what would be the time of exposure if an equivalent dose of 200 rem, all right, 200 rem is considered a moderate amount of radiation, all right. Uh, how long will it take if this is the rate of equivalent dose, 1.7 raised to the negative 3 rem per second? So in how many seconds will the tumor, all right, get 200 rems, right? So what we do is just, of course, multiply that by the conversion factor, meaning in 1 second, okay, there is only 1.7 raised to the negative 3 rems of equivalent dose. All right, so if we do our math, multiplying 200 by 1 and then dividing it by 1.7 to the negative 3 cancels the unit rem cancels out, and we get, all right, the time of exposure needed, which is equal to 1.2 times 10 to the fifth power seconds. So that is the length of time that is needed, all right, for that amount of equivalent dose, 200 rems, all right, given that the equivalent dose per second for this particular gamma source, all right, is 1.7 raised to the negative 3, all right. Uh, 1.2 times 10 to the 5th seconds, when converted to hours, of course, we just divide this by 3,600 seconds, and we will get this length of time in hours, which is in two significant figures equivalent to 33 hours. Right? So in other words, in using this treatment of cancer, okay, gamma radiations, all right, the equivalent dose that we calculated here, all right, 1.7 raised to negative 3 rem, all right, this is the amount of equivalent dose in 1 second, all right. Uh, for the target, what do you call this? Body, for the target body, in this case, the cancerous tumor or tissue, body tissue, for it to be able to be exposed to 200 rems, okay, it would require 33 hours of continuous exposure. All right? In other words, what is being implied here is using this treatment or cancer treatment using cobalt-60 as the source of gamma radiation is relatively safe. All right? Because you are not going to what we call expose, all right, the tumor or the body with this amount of equivalent dose of 200 rems all at once. That is not what is done here. All right, only 1.7 times 10 to the negative 3 rems of equivalent dose per second. All right, and it would take 33 hours. All right, almost 1.5 days for this amount of equivalent dose, okay, to be received uh, by the body, all right, given this equivalent dose rate. All right, so we have answered all the questions in this video tutorial. So thank you very much and see you in our future video tutorial. Thank you very much. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.